Okay, inequalities day one. I don't know what your background knowledge is on inequalities, but I'm going to go through it kind of thoroughly at the beginning here, and tomorrow we'll begin solving them. So an inequality is a mathematical sentence formed by placing one of the following symbols between two expressions. Now, everything you've done since you've been working with me has been about equal or equality, right? So you're used to the equal sign, which means the left side is equal to the right side. Now we're going to inequality where we may not be equal to. So when we look at this symbol here, this symbol is the less than symbol. Okay? This symbol here is the greater than symbol. This here is the less than. But this little line underneath tells us or equal to. And this one would be greater than or equal to. Okay, so these little lines underneath tell you could also be equal to, right? And then remember, the less than sign. What a lot of teachers teach is that you have an alligator here, and the alligator always eats the bigger number. And when we read these, we read from left to right. So if the bigger number is on the right, that means the number on the left is less than the number on the right. Okay, so let's take a look here. We had to translate these inequalities here. Here we would say A is, since the alligator is eating A, that tells us A is bigger, so A is greater than B. Okay, here we would say C is less than D. Here we would have E is less than or equal to F. And then here, H is greater than or equal to G. Okay, so knowing what these symbols mean is critical, and how to read them from left to right. Now, a solution to an inequality is the value of the variable that makes the equation or inequality true. Okay, so unlike an equation generally has one answer that'll make it true. An inequality could have several. Okay, so when we look down below, right, translate the following inequality and then determine if the value of the variables are solutions to the inequality. So we're given 5 values on the right side, and we want to determine if they make the inequality true. So here, we would translate this as x is greater than 4. Okay, so if I plug 0 in for x, is 0 greater than 4, right? That is false, so no, that is not a solution. Okay, is -4 greater than 4? Is the alligator eating the bigger number here? No. Is 15 greater than 4? That is yes, so that is a solution. So 15 is a solution. Is 4 greater than 4? No, 4 is equal to 4. It's not greater than 4, so this is a no. And then is 6 greater than 4? That is a yes. Okay. The next one, x is less than, in this case, or equal to -3. Okay, so first one is -10 less than or equal to -3, right? Is -10 smaller than -3? That's a yes, right? You're in debt more dollars. Is -3 less than or equal to -3? Since they're equal, right, and that little line's underneath, that is a yes. Is 12 less than or equal to -3? That's a no. Is 4 less than or equal to -3? That is a no. Is -5 less than or equal to -3? -5 is smaller, therefore it is yes. Okay. And the last one here, x is greater than or equal to 20. So is 20 greater than or equal to 20? Yes, that's a solution. Is 30 greater than or equal to 20? That is a solution. Is negative 20 greater than or equal to 20? That's not a solution. Is 19 greater than or equal to 20? That is not a solution. And is 20 greater than or equal to 20? That is a solution. Okay? So being able to read these inequalities and determine what numbers are solutions is very, very important. Now, graphing inequalities. There's two parts to it. One, if you have the less than or greater than symbol, what we use is an open circle because we're not equal to. Okay, so we do not include that value. If we have less than or equal to or greater than or equal to, you will use a closed circle, meaning that value will be equal. All right, the second part is you shade. Okay, now when we shade, if x is less than or equal to, you will shade to the left. You will shade all the numbers that are smaller than that number. If x is greater than or equal to, you will shade right. Okay, so when we look at down below, graph the following inequality. X is less than or equal to 6. What we're going to do is we're going to go to 6 on the number line. Because we're equal to, we're going to use a closed dot. All right. So we're going to go to 6. We're going to put a closed dot. And we want to shade all the numbers that are less than or equal to 6. All the numbers smaller than 6 will be to the left. So that is the way we shade. Okay. Next one. X is greater than negative 3. This is just greater than, so we know we're going to have an open dot because we're not equal to. So we go to negative 3, we put an open dot. Now we want all the x values that are bigger than negative 3. Which way does that end up being? To the right. All right, next one. X is less than negative 4. So this tells us we're going to have an open dot. So we're going to go open dot on negative 4. Since we're less than, we're going to go to the left. And x is greater than 7, right? This tells us we're an open dot. So we're going to go to 7 and put an open dot. And we want all the numbers that are greater than 7, which lay to the right. Okay, and that's how we graph these inequalities. Now, how do we write a graph for it, or write an inequality for the graph? First off, you know it's going to be x. And in this case, since it's an open dot, we know we're not equal to, and we're shaded to the right. So all the numbers, right, are bigger than 1. So we say x is greater than 1, and done. Okay, the next one, x, since we're to the left, we know all those values are smaller, so we're less than, right? We're not equal to because it's open dot, so it's just less than. And then, what number are we less than? 5. And finally, here we have x. Since we're to the left, we're less than, right? And since it's a closed dot, we're also equal to. So it's less than or equal to what number? 4. So going into tomorrow's lesson, we need to have this, mastered. It's not very hard. Try the homework and let me know if you have any questions.